Hey everybody, welcome to the exciting conclusion of our remote learning lesson on section 6-9, vertical motion problems. If you'll recall from the first installment of the lesson that we were introduced to this formula, which is d equals rt minus 5t squared. And this formula can tell us how high an object is based on a certain initial upward velocity and based off of a certain amount of t time. That sort of addresses this first question, that if we want to know how high something is after a certain amount of time, we can plug that value in for t to figure out how high the object will be. The other thing this formula can do will be it will also be able to tell us when an object will achieve a certain height based off of an initial upward velocity. Remember that when an object goes up in the air, that it will often achieve a certain height at two different times, on its way up and also on its way down. And why does the sun wear sunglasses? It's because it always has the sun in its eyes. Anyway, to remind you of the problem on which we were working in the previous video, that we have a situation where a ball is thrown with an initial upward velocity of 35 meters. We answered a couple questions. One, we answered how high the ball will be after 3 seconds. And we were able to determine that it will be 60 meters high after 3 seconds. And we were asked how long, or rather, when will the object be 50 meters high? After taking this information in the formula, putting it into standard form, and using the quadratic formula, we were able to figure out that it happened after 2 seconds and 5 seconds. So we have two more questions to address. And the first one is, when will the object be 70 meters high? So if you'll recall, when we are asked a question pertaining to when, we are going to take our height or distance above where the object was thrown, substitute it into the formula as step one. Step two, we're going to rewrite this in standard form, but we want to keep a positive as just simply a good habit when it comes to rewriting things in standard form. Looking a lot like that. We're going to identify our a value, our b value, and our c value. And because we're talking about the same problem with the same upward initial velocity, all that's changing is our c value, because we're changing the question about when an object is a certain height. So we are going to plug that information into our quadratic formula. Thusly, and 70. Once again, we're going to clean this thing up a little bit first. I'm going to use desmos.com/scientific to perform that basic calculation. When I plug that in, what I get back is a negative 175. Now, if we take the square root of a negative number in the real number system, we cannot take the square root of a negative number in the real number system. I've mentioned to you that we have this whole number system called the complex number system, which allows us to do that, but we're not operating there. We're operating in the real number system. And so, since we can't take the square root of a negative number, the way that we interpret this information within the context of this problem is that simply the ball never reaches a height of 70 meters. Okay, so if you're doing this work and you're being asked when a ball or an object reaches a certain height, and you get a negative radicand, or the number inside the square root is negative, we interpret that as meaning the ball will never reach that height. Okay? The last question we're going to do, pertaining to this single situation of a ball being thrown upwards with an initial velocity of 35 meters per second, is when will the ball be back on the ground? A key word here is when. Because this is a question about when, we need to remember that we're going to use the quadratic formula to solve for a certain value of time. Now, the other thing is, when will the ball be back on the ground? Well, the way that we're going to interpret that is if the ball is back on the ground, that means that its height is 0 meters. So that's the height, the value for d, that we are going to substitute into the quadratic formula. Excuse me, not into the quadratic formula, but into our vertical motion formula. So this will just be written as 0 equals 35t minus 5t squared. And this is after substituting a value of d, 0, in for d. Just as a good habit, we're going to keep our a value positive, and when we put this thing into standard form. So if I add 5t to both sides and subtract 35t from both sides, what we're going to get is 5t squared minus 35t, and that, of course, is all equal to 0. There are other ways of, rearranging that, but, ultimately, whichever path you take, that's what you get. Now, for this situation, our a value is still 5. Our b value is still negative 35, but in this case, our c value is 0. So when you don't see a constant out here, what that means is that your c value is 0. All right, so for our grand finale here, we're going to get this thing set up. Substitute our values in. Now, we're going to clean this up. When we substitute this information into our calculator, we get 1,225. When you go to substitute the rest of this information into the calculator, we're going to get two values. Whoops. There we go. We're going to get two values, 0 and 7 for t. Now what this means is, well, how do we interpret these two values? Well, 0, right, we wanted to know when the ball got back on the ground, or probably a better way of saying that is when the ball gets back to the height from where the object was thrown. This one is going to be our answer. And so I'm going to state the answer, and then I'm going to explain why. So the ball will hit the ground after 7 seconds. Oops. After 7 seconds. So that's the answer to the question. The reason why we're getting this second value of t equals 0, so in order to explain that, we're just going to go back to that original awesome drawing that you saw. Okay. So we can think of this location here as when the ball hits the ground after 7 seconds. The reason why we get that t value of 0 is essentially the moment that the ball is put into motion. The ball is at that original height. So the reason why we get this value t equals 0, once again, is because that's the moment or instant that the ball is put into motion. And then after 7 seconds, the ball is getting back to the original height from where it was thrown. I know this drawing doesn't match that information exactly, but that's essentially the idea. That's why we're getting two answers. And so essentially we're kind of neglecting or ignoring that answer t equals 0. Okay, so as always, make sure when you're going through your work that you refer back to the video, that you take notes, and as always, reach out to me, of course, if you have any questions. That's all for now. I miss you guys. I hope you and your families are well, and we'll talk to you soon.